Auxiliary elements. There is much more in our conception of the problem at the end of our work than was it as we started working. Progress and achievements. As our work progresses, we add new elements to those originally considered. An element that we introduce in the hope that it will further the solution is called an auxiliary element. There are various kinds of auxiliary elements. Solving a geometric problem, we may introduce new lines into our figure, auxiliary lines. Yes. Solving an algebraic problem, we may introduce an auxiliary unknown, auxiliary problems. An auxiliary theorem is a theorem whose proof we undertake is in the hope of promoting the solution of our original problem. There are various reasons for introducing auxiliary elements. We are glad when we have succeeded in recollecting a problem related to our unsolved before. Related to ours and solved before. It is probable that we can use such a problem, but we do not know yet how to use it. For instance, the problem which we are trying to solve is a geometric problem, and the related problem which we have solved before and have now succeeded in recollecting is a problem about triangles. Yet there is no triangle in our figure. In order to make any use of this problem recollected, we must have a triangle. Therefore, we have to introduce one by adding suitable auxiliary lines to our figure. In general, having a recollected formally solved related problem and wishing to use it for our present one, we must often ask, should we introduce some auxiliary elements in order to make its use possible? The example in the section 10 is typical. Going back to the definitions, we have another opportunity to introduce auxiliary elements. For instance, explicating the definition of the circle, we should not only mention its center and its radius, but we should also introduce these geometric elements into our figure. Without introducing them, we could not make any concrete use of the definition. Stating the definition without drawing something is mere lip service. Trying to use known results and going back to the definitions are among the best reasons for introducing auxiliary elements, but they are not the only ones. We may add auxiliary elements to the conception of our problem in order to make it fuller, more suggestive, more familiar, although we scarcely know yet explicitly how we shall be able to use the elements added. We may just feel that it is a bright idea to conceive the problem that way with such and such elements added. We may have this or that reason for introducing an auxiliary elements, but we should have some reason. We should not introduce auxiliary elements wantonly. Example. Construct a triangle. Being given one angle, the altitude drawn from the vertex of the given angle, and the perimeter of the triangle. We introduce a suitable notation. Let alpha denote the given angle, h the given altitude drawn from the vertex A of the alpha, and p the given perimeter. We draw a figure in which we easily place alpha and h. Have we used all the data? No, our figure does not contain the given length p equal to the perimeter of the triangle. Therefore, we must introduce P. But how? We may attempt to introduce P in the various ways. The attempts exhibited in figure 9-10 appear clumsy. If we try to make clear to ourselves why they appear so unsatisfactory, we may perceive that it is for lack of symmetry. In fact, the triangle has three unknown sides, A, B, C. Yes. We call A as usual the side opposite to large A. We call small a as usual the side opposite to large A. We know that A plus B plus C equal P. Yes. Now, the side of B and C plays the same role. They are interchangeable. Our problem is symmetric with respect to B and C, but B and C do not play the same role in our figure 9-10. Placing the length P, we treated B and C differently. The figure 9 and 10 spoils the natural symmetry of the problem with respect to the B and C. We should place P so that it has the same relation to B as to C. This consideration may be helpful in the suggestion to the place the length P is as in figure 11. We add to the side of A of the triangle the segment CE of the length B on the one side and the segment BD of the length C on the other side, so that the P appears in the figure 11 as the line ED of the length. B plus A plus C equal P. If we have some little experience in solving problems of the construction, we shall not fail to introduce into the figure, along with ED, the auxiliary line AD and AE. Each of which is the base of an isolated triangle. In fact, it is not unreasonable to introduce elements into the problem which are particularly simple and familiar as isolates the isosceles triangle. We have been quite lucky in introducing our auxiliary lines. Examining the new figure, we may discover that angle EAD has a simple relation to the given angle alpha. In fact, we find using the isosceles triangle, triangle ABD and triangle ACE that angle DAE equal alpha over 2 plus 90 degrees. After this remark, it is natural to try the construction of the triangle DAE. Trying this construction, we introduce an auxiliary problem which is much easier than the original problem. The teachers and the authors of textbooks should not forget that the intelligent student and the intelligent leader are not satisfied with by the verifying the steps of the reasoning. I'm sorry. The teacher and author of our textbooks should not forget that the intelligent student and their intelligent leader are not satisfied by verifying that the steps of the reasoning are correct, but also want to know the motive and the purpose of their various steps. The introduction of the auxiliary element is a conspicuous step. If a tricky auxiliary line appears abruptly in the sphere without any motivation and solves the problem surprisingly, intelligent students and leaders are disappointed. Yes, like me. They feel that they are cheated. Mathematics is interesting insofar as it occupies our reasoning and inventive powers. But there is nothing to learn about reasoning and invention if the motive and purpose of the most conspicuous step remain incomprehensible, right? to make such steps comprehensible by suitable remarks, as in the foregoing under 3, or by carefully chosen questions and suggestions, as takes a lot of time and effort, but it may be worthwhile. Thank you.